The last topic that we're going to look at very briefly is one that's called electrolysis. Electrolysis allowed us to separate hydrogen and oxygen from water. In other words, we took water and we broke it into hydrogen and oxygen gas. Electrolysis is the use of electrical energy to create a chemical reaction that would otherwise be non-spontaneous. Let me write that down. The use of chemical energy, electrical energy to create a chemical reaction that is non-spontaneous. So therefore, what is delta G? Positive or negative? Positive delta G. So if we have a reaction that is not spontaneous, then the reaction doesn't normally happen. We are forcing it to happen. Forcing reaction by using energy. In this case, it's energy in form of a battery. So it's not producing voltage. We are forcing voltage to happen to make the reaction actually go in the reverse. This is what happens if you have a rechargeable battery, or you have a phone or an iPod or an iPad or any of that, or even your battery in your computer. When you plug it into the wall or into a docking station, you're taking the reaction that has completed, and therefore your device doesn't work anymore, low battery, dead battery. You're plugging it in, it's forcing the electrons to move in the opposite direction so that when you turn the device on again, the reaction can occur spontaneously in the forward direction. So it's like you're taking the reaction and you're turning it back, and you're allowing it to go forward again. So that's what this electrolysis is. In this case, zinc and copper can produce voltage, but not when this is the anode and that is the cathode. So this is a little bit backwards than we've seen before, but that's the idea with electrolysis. Electrolysis is forcing electrons to move in the direction opposite to their natural flow. If you'll notice where the flow of electrons are, this is copper now and that's zinc. In the previous slides, it was the reverse. So copper is not usually the anode, and zinc is not usually the cathode. So to make that happen, we have to force it backwards with a battery, and that's what electrolysis is. There are lots of applications of electrolysis, but we're going to look at just a couple. We're going to talk about that. One of them is purification of ores. In the late 19th century, aluminum was actually more valuable than gold, which is not the case anymore. Think about aluminum siding on a house. We have no trouble with aluminum, and certainly we would not put gold siding on our house because gold is quite valuable. But back in the 19th century, aluminum was actually more valuable than gold because no one knew how to purify aluminum in large amounts. And so once this electrolysis process came about, aluminum was actually able to be removed from ores, like mining. When you dig in the ground and you have rocks that have material inside of it, how do we get that out? We're not going to build a house with a bunch of rocks on the outside. If we want aluminum siding or aluminum chairs or whatever it is, we want to have that aluminum removed, and we want to melt the aluminum down and use it to shape it into all kinds of shapes, wires and so forth. Same with copper. Copper is also removed from ores by electrolysis, which can yield pure copper, and we can use copper to cover the roof of a building or something else. So pieces of copper and other metals are often extracted from their ores using electrolysis. Another example is electroplating. Here, a piece of, let's say, a piece of metal, often it's metal, is covered with another metal. So if you have any cheap jewelry, costume jewelry, or you take a walk through Claire's, for example, and you see some very inexpensive earrings or bracelets or necklaces, most of the time those materials have been electroplated. In other words, there's a cheap metal and then it's covered with a coating of some other metal. So it looks like gold, but it's really not gold at all. It's some other, the metal itself could be covered with a very thin layer of gold, but the base metal, the majority of the composition of that jewelry, is probably something else. And some years ago, there were some jewelries, I think from one of those types of stores or the dollar store or something like that, that was recalled because the material was made outside the United States, and wherever it was manufactured, the base metal was lead, which of course can be very damaging to brain cells when ingested. And so these pieces of jewelry had a component that was made of lead covered with some other metal. And so if you happen to bite down on it, or it broke apart and it got into your bloodstream or whatever, it could cause brain damage. So in the United States, we have lots of rules and regulations about what materials can be used for certain things. And you can't buy lead jewelry. You can't have lead paint and so forth. So this electroplating is a process, again, by which one piece of metal is covered with another. So if you have what looks like sterling silver, it might not actually be. It could be something that's plated on the top of it. And again, it's a reaction that's forced to happen because it's electrolysis, reaction that's forced to happen that wouldn't normally happen.